Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The rate of N-methylation, quaternization, with methyl iodide and SN2 reaction depends on the nucleophilicity of the amine nitrogen, which is influenced by steric hindrance and lone pair availability. Moving on to the next step. Triethylamine is an acyclic tertiary amine. Although it is a tertiary amine with good basicity, it suffers from significant steric hindrance due to the 3 ethyl groups surrounding the nitrogen. The ethyl groups can adopt conformations that partially shield the nitrogen lone pair. Additionally, in acyclic tertiary amines, the nitrogen lone pair is in a pyramidal geometry, but the approach of the electrophile is hindered by the 3 bulky ethyl chains. This makes it the least reactive of the 3 toward SN2 methylation. Moving on to the next step. Analyze structure B, quinoclidine, 1-as-a-bicyclo, 2.2.2 octane. Quinoclidine is a bridged bicyclic tertiary amine where the nitrogen is at the bridgehead. The 3 ethylene bridges hold the alkyl groups rigidly away from the nitrogen, completely eliminating the B strain, backstrain, that plagues acyclic tertiary amines. The lone pair on nitrogen is perfectly exposed and unhindered from the front face, no backside steric interaction from the bridges because they fan away. This makes quinoclidine an exceptionally good nucleophile. It reacts faster with methyl iodide than triethylamine by a large factor, approximately 30-fold or more. Quinoclidine is the most reactive. And for the final step, DAPCO has 2 nitrogen atoms in a cage structure. Like quinoclidine, the bridged bicyclic framework holds the substituents away from nitrogen, providing low steric hindrance. However, once one nitrogen is methylated, quaternized, the resulting ammonium group on the other end strongly withdraws electron density through the cage, reducing the nucleophilicity of the second nitrogen. But for the first methylation event, DAPCO is less reactive than quinoclidine because A. The second nitrogen in DAPCO is slightly electron withdrawing through induction even before quaternization, and B. The cage is slightly more constrained. DAPCO reacts faster than triethylamine due to reduced steric hindrance, but slower than quinoclidine. So C is intermediate. B. Quinoclidine, C. DAPCO, A. Triethylamine. This corresponds to answer option CBCA. Why other options fail? A. ABC, incorrect, triethylamine is most hindered, not least. B. ACB, incorrect, same reasoning. D. BAC, incorrect, triethylamine is more hindered than DAPCO. Therefore, the correct answer is C. Therefore, the correct answer is option C.